Hey, what's up you guys? Now in this video we are going to be covering two main subtopics. The first subtopic is the third subtopic of this chapter, which is chapter 4.3, laws of logarithms. And this subtopic, I'll cover everything you need to know about log. Okay, how do you apply the properties into questions? Okay, how do you solve them using the properties of logs? The second subtopic I'm going to cover is the application. Application of what? So basically it's going to cover everything you have learned in this chapter. So you've learned about indices, you've learned about surds, and now you're going to learn about logs. Okay, so the final subtopic is where you will combine everything. Okay, you must learn how to apply what you have learned into word problems, and that is what we'll be covering in this video. So without further ado, let us get started. So there are a few properties when it comes to log, right? There are few properties that you have to learn. The first one is log. Whenever you see the word log, if it's not written, there is no base value written, automatically you know this is log base 10. Okay, automatically you don't have to ask anything. When you see log, it means log base 10. Okay, and everything you see in your calculator, everything you use in your calculator is log base 10. Okay, your log button there, although it's only written log, right, it means log base 10. Okay, so that's the first thing you have to know about log. The second thing you have to know is ln. What is ln? Ln is basically log base e. Okay, this is not log. Okay, this is log base e. Okay, so whenever you see some is written log 5, what does this mean? This means log 5 base e. Okay, so this is what it means by ln. Okay, the next thing you have to know is log 1 base a is equals to 0. What does this mean? It means that any log value, okay, whether it's log base 5, log base 10, any value, any log that has 1 as the value, so that means log 1 base 10 or log 50, log 1 base 50, any log value, any base value, if you see is log 1, automatically you know it becomes 0. Okay, it is fixed, right? You cannot change this. Any log value, whenever you see log 1, regardless of what the base number is equals to 0. Okay, next thing you have to know is number 4. The fourth property is log AA is equals to 1, which means if you see the value of the log is the same as the base value. Okay, so for example, let's say you see log 10 base 10 or log 5 base 5. When you see the value and the base are the same, automatically you know it's equals to 1. Is equals to 1. Okay, so that is something you have to pay attention. The next property that you have to learn is this: log b power n base a is equals to n log b base a. What does this mean? It means that whenever you see a log value has power, so in this case b power n, the power can be shifted to the front of the log. Okay, so this power here can be shifted to the front, so it becomes n log b base a. Okay, so for example, let's say you have this log 3 square base 10, so the square can go to the front, so 2 log 3 base 10. Okay, or for example log 5 cube base 50, let's say base 50, so the cube you can bring to the front, so 3 log 5 base 50. You can do this. Okay, this is one of the application of, or one of the properties. Okay, you can shift the power to the front. Okay, the next one you have to know is this. Now you have learned indices, correct? The first subtopic, indices. we know that whenever, for example, a cubed times a square, whenever you see two indices multiply together, what do you do with the power? You add them up, correct? Whenever it's multiply, you add them up. Whenever it's divide, you minus the power, correct? But in logarithm, it's the opposite. So for example, if you have log m base a plus log n base a, okay, when you see it's plus, the power here, this log value, you have to times. So what happens to that is it becomes log mn base a. The m and the n value you multiply. Okay, so it's opposite from indices. Indices is whenever you see multiplication, the power you have to add them up. Or if you see divide, the power you have to minus, okay, subtract. But in the case of log, when it is addition, you have to multiply the value of the log. Okay, so m and n you multiply. If it's divide, if it's minus, you have to divide. Okay, so this is one of the properties that you have to know. So the seventh one is basically the dividing one. Okay, so let me write this down. Log m base a minus log n base a So this is what happens. Whenever you see it's minus, you have to divide. So m divided by n. Okay, so this is the seventh property. And the final property that you have to know is this: log b a base a. Whenever you see log b base a, any number, okay, if you don't want the base to be a, in this case base a, correct? But if let's say you don't want it to be a, you want it to be c, what you can do is you change your base to c, and then the top one here comes up here, and the bottom one goes down. So in this case, log a base c. Okay, so now you successfully change the base of the log. Okay, when do you apply this? So usually you will encounter questions where they will want you to switch the base value. So for example, they give you log 5 base 2, or maybe log 10 base 2. Okay, they want you to change this to log base 3. So what do? You change to log 10 base 3 divided by log 3 and log 2 base 3. So now you have successfully changed the base value of the log, which is log base 3. Okay, so in some questions they want you to change the base. So because of that, you have to use this formula. Okay, so this is what you have to know for logs. Given that log 4 base 7 equals 0.712 and log 5 base 7 equals 0.827, calculate each of the following. So in this case, they gave you this, correct? They gave you these two, and they want you to use this value to find out what's the answer for all this. Okay, so that's what you're going to do. So first thing you want to do is, you notice here is what? Base 7, correct? Base 7. So all of these are base 7. So that's good news. You don't have to change the base, okay? Because everything is already the same. So the only thing you have to change is the value here, okay? Because you don't have this value. You only have 4 and you have log 5. So now, let's solve one by one. Log 1 over 4. What I'm going to do is I'm going to change this to improper fraction first. So it becomes 5 over 4. Now remember, I told you, whenever you see log m plus log n, what happens is it becomes multiply, correct? So mn. Okay, you will multiply. Whenever you see addition, the value of the log, you have to multiply. So in this case, it's what? Divide. So if divide means what? Divide means minus. Okay, so when you break it down, it becomes log 7 log 5 base 7 minus log 4 base 7. So when it's minus, the 5 will have to divide by 4. So you get 5 over 4. So in other words, now you have log 5, which is here, 0.827 minus log 4 base 7 is 0.712. So your answer should be 0.115. Okay, this is your answer. Next, B, log 28 base 7. So you know that you can break 28 into what? 7 times 4, correct? 7 times 4 is 28. So when you know it's multiply, you can change this to addition. When the value is multiplied, change to addition. So log 7 base 7 plus log 4 base 7. So in this case, 7 plus 4, correct? So here becomes, remember I told you whenever you have same value as the base, like for log AA is equals to 1. So if it's the same, you can make it equals to 1 plus log 4 base 7 is, you've gotten here, 0.712. Answer is 1.712. Okay, so now last question, log 100. Log 100 base 7. So what can you do to get 100? You can take log 5 times 4. 5 times 4 is 20. 20 times 5 again. So 5 times 5 times 4, or you can do like this. Okay, or I change to 5 times 5 times 4. 5 times 5 is 25, times 4 is 100. So now, notice all these are multiply, correct? So that means you can add up the log. So log 7, 5. So 5 times 5 is square, correct? So I write here 5 square plus log 4 base 7. So remember, I told you when you have something like this, log A, B, and then n, the power you can shift to the front, correct? So you get n log B power, log B base A, correct? So in this case, you're going to apply the same thing. The 2 you can bring in front. So 2 log 5 base 7 plus log 4 base 7. So what's your answer? 2 times 0.827 plus log 4 base 7 is 0.712. So your final answer should be 2.366. Okay, so this is your answer. Solve the following equations. So when you ever encountered questions like this, I want you all to know this. Whenever you see something like this, right? For example, log AX equals to 10. Okay, we know that, for example, x plus 1 equals to 10. So if you want to find x, what do? You bring the plus 1 to the opposite side, correct? So when plus 1 you bring the other side becomes minus 1, correct? Or if let's say you have encountered 2x equals to 10. So when you bring the times 2 to the other side, you get divide by 2, correct? Now, this is how the basic mathematics work, okay? When it's plus 1 on the left, you bring the other side becomes minus 1. When it's times 2, for example, you bring to the opposite side, you get divide by 2. There's always the opposite sign. But for log, when you bring this log A to the opposite side, what actually shifts is this base here. So the base, when you shift to the opposite side, the x value remains. The A, the base value of the log, will push whatever value that was initially on the right hand side, it make it become the power. So in this case, it becomes A power 10. You notice that the value on the right becomes the power. The A, which is the base of the log, will push the value and become the base of the new indices. Okay, so for example, if let's say I have log x base 50 equals to 25. Okay, let's say. So when I shift the log base 50, it becomes 50 power 25. Okay, so the base will push the whatever value that was initially on the right, push it become the power, and it becomes the new base of the indices. Okay, so this one, and it works both ways. So that means if you see something like this, x equals to 5 power 2, the 5 you can actually bring it there. Okay, or let's say I change the question, it becomes like this. If the question asks you like this, 10 equals to 5 power x. Okay, if you want to solve what is x, so what you can do is you can take the 5, bring to the opposite side, it becomes log 10 base 5 equals to x. Okay, so you notice that in this case here, you shift the base of the log, you bring to the opposite side, it pushes the value up. Okay, so it becomes 50 power 25. But in this case, you're going to take the base of the indices, bring to the other side, it becomes a log value with the base from the other side just now. So that means 5. The 5 you bring the other side, to the left it becomes log base 5. Okay, so this is how it works. So you're going to implement this for this question. So you see question 1, log x base 2 is equals to 5. So which one are you going to shift? Of course you're going to shift the 2 here, correct? So it becomes, you shift to the other side, it becomes x equals to 2 power 5. So your answer is 32. Okay, what about B? You have log x base 8 equals to 3. So what you're going to do is you're going to take 8 here, shift to the other side, it becomes x equals to 8 power 3, which is 712. Sorry, not 712, but 512. My bad. Okay, alright, next. Evaluate each of the following without using a calculator. So if you notice that all of these log here, they are the same base, correct? 33, 444. So there's really nothing to worry about because you don't have to change the base of the log. And then if you notice here is plus minus, correct? So I told you whenever you see plus minus, you must multiply the value of the log. So in this case, log base 3. Now you notice 21 plus 18. So that means you have to multiply 21 times 18 minus 14. So divide by 14. Okay, so your answer should be log base 3. Here is 27. So you can change to 3 power 3. Correct? So it becomes what? The power you can bring to the front. So 3 log 3 base 3. So I told you all before, whenever you see the value and the base are the same, it becomes 1. So the answer is 3. Okay. Question B. 2 log 4. Okay, I don't want to copy the question again. So what happens here is you're going to bring all the value to the top first. Okay, all this. Okay, so remember I told you all, whenever you have the power like this, you can bring to the front, and it also works both ways. So that means if you have 3 log 4 power 3, this 3 you can bring up, it becomes log 4 cube base 3. You can do that. Okay, so I'm going to do that first. You know why? Because if I don't do that, I cannot combine the logs. Okay, I cannot combine the logs here, because here you have 2, here you have 1 over 2, so it becomes very confusing. So better I shift everything to the top. So 4 base 4, 2 power 2 minus log 9 power 1 over 2 base 4 plus log 12 base 4. So here, right, actually you can straight away combine them. 4 power 4 minus log 1 over 2. When you have 9 power 1 over 2 is the same as square root of 9. Answer is 3. So log 3 base 4 plus log 4 12 base 4. So now what you can do is you can combine them. So now log all base 4, right? So here 4 and then 3, here's what? Minus, so it's divide. So 4 over 3 plus means what? Times 12. Okay, so you get log base 4 and 16. Okay, so 16 is actually the same as 4 square, correct or not? So the 2 you can bring to the front. So 2 log 4 base 4 is answer is 2. Convert each of the following to natural logarithms and evaluate them. So what is natural logarithm? Natural logarithm means log base e. Okay, log base e. So in other words, it's the same as ln. Okay, so that means they want you to change the base. Okay, so there's only one property that can make you change the base. I already told you all just now, which is this. If let's say you have log b base a, you want to change the base of the log, you have to make it into a fraction. The b will be on top, the a will be at the bottom, and then you will change the base according to the base that you want. Okay, so in this case, I change to base c. So I get log b base c over log a base c. Okay, so now I successfully change the base of the log. So you're going to do the same here. Why? Because they ask for natural logarithm. They want you to change the log into log base e. Okay, log base e means ln. Okay, so you have to change the base. So to change the base, you have to change it into fraction. So your answer here should be ln 225. Remember, natural logarithm means log e. Log e is the same as ln. So I'm going to use ln straight away. Ln 225 divided by ln 7. Okay, the base will come here and the top value here will come up. Okay, so you just key this in to your calculator. You should get your answer straight away. Your answer should be 2.7833. Okay, next, log 324 base 9. So this one you change to 324 over ln 9. Okay, key into your calculator, you should get 2.6309. Okay, alright, next question. Given log 2 base 3 equals to t, yeah, express each of the following in terms of t. So now they want you to use this, correct? And if you want to use this, you must make sure the log is base 3. So the first thing you have to do to solve all this is to change the base value, because all these are different base. Here is log base 2, log base 9, log base 2. So you cannot use all of this. You have to first change the base. Change to what? Change to base 3, because that's what you are. That's what is given to you. You only have base 3. So you use base 3. So here you should get question 1. Log 9 base 3, log 3 base 3. Okay, remember I'm still using the same property just now. Okay, I'm changing the base. So log 9 base 3 is what? 3 square, correct? Log 3 base 3 is 1. So your answer here is 2. Okay, why? Because this guy here you can bring to the front. So 2 times log 3 base 3. So answer is 2. Okay. Next question. Log 8 base 9. So first thing, change the base. So log 8 base 3 over log 9 base 3. So 8 base 3. 8 is equals to what? 2 power 3, correct? So log 2 power 3, here base 3, over log 3 square here, base 3. Okay, so what do you get here? The 3 I can bring to the front. So I get 3. Log 2 base 3 is what? T, correct? So here t divided by 2. So this is your answer. Alright, next, log 18 base 2. So let's do a bit faster here. Log 18 base 3 over log 2 base 3. Okay, so 18 is equals to what? 18 is equals to 9 times 2, correct? Over log 2 base 3 is t. So now I can change this to log 9 base 3 plus log 2 base 3 over t. So 9 is actually equals to what? 3 square, correct? So I can write like this: 2 log 3 base 3 plus log, plus t, right, over t. So your final answer, let me write up here. Final answer should be 2 plus t over t. This is your answer. Alright. Solve the following equations by giving answers in 3 decimal places. So question A. Now, this kind of question, right? Remember, when we learn indices, I told you that when you encounter questions like this, you have to make them become the same base. So for example, if let's say you have 2 power 5 equals to 8 power x, what you can do is you can change this into the same base. So you can change this to 2 power 5, this one become 2 power 3x. Okay, because 8 is also equivalent to 2 power 3. So you can make them become the same base, then you can compare. But in this case, you have 4 and 7. Okay, you have 4 and 7. How do you make them become the same base? Well, the thing is you can't. So what you do is you can still make them become the same base, but instead of using indices, you use log. So it becomes log 4 power 2x minus 1 equals to log 7x. So what is this? Base. The base is base 10. Log base 10. You can make them become the same base by adding log. Okay, so now you have log base 10 on both sides. Okay, so now you can say they are the same base. So what do you do with the power? You can bring the power in front. Same goes to this. You can bring it in front. So it becomes 2x minus 1 log 4 base 10 equals to x log 7 base 10. Okay, so now you can shift them, rearrange such that so that you can solve the value of x. So you get 2x minus 1. I'm going to bring this to the other side. Okay, so it becomes divide. So you get x log 7 base 10 divided by log 4 base 10. Okay, so when you count this in your calculator, you should get, here will be 2x minus 1 equals to 1.4037x. Okay, so now you can rearrange. So 2x minus 1.4037x equals to 1. So you get 0.5963x equals to 1. So what is the x value? X value should be equals to 1 over 0.5963. So I straight away write the answer. You should get 1.677. This is your answer. Question B. Same thing. One is base 5. The other one is base 79. Right? Both are indices. So there is no way for you to make them become the same base. So what do? You add log. So log base 10 equals to, now the 2x minus 1 I'm going to bring in front, so become 2x minus 1, and then the other one is x minus 1 come in front. Here become log base 10 79. Okay, so same thing, I'm going to do the same exact thing. So you get 2x minus 1 equals to x minus 1, here is log 79 base 10 divided by log 5 base 10. Okay, so here remains 2x minus 1 equals to, when you divide, you should get 2.7149. So I'm going to expand it, so you get 2.7149x minus 2.7149. Okay, so I'm going to rearrange this. You should get 2x minus 2.7149x equals to negative 2.7149 plus 1. Here you should get negative 0.7149x equals to negative 2 plus 1, you get negative 1.7149. So x is equals to 2.399. Why I put 3 decimal place? Because they have mentioned here they only want 3 decimal place. So this is your answer. The price of a house after n years is given by 260,000 9 over 8 power n. Determine the minimum number of years for the price of the house to exceed 300,000 for the first time. So you have the price of the house. This one will calculate for you the price of the house. You want to count up to what extent, how many years do you need to achieve $300,000. So that's what you're going to do. So you're going to form your equation through 260,000 times 9 over 8 power n equals to 300,000. Okay, you count this first. You want to know at what year do you get $300,000. I know the question asking you exceed $300,000, but now you find equal first. You want to find out how many years. So first thing you want to do is you want to shift the 260,000 to the opposite side. So you get 9 over 8 power n equals to 300,000 divided by 260,000. You should get 15 over 13. Okay, now you have the power here that you're looking for. So what you're going to do is you're going to make both sides become log, because you want to find the value of n. So you get here log base 10, okay, 9 over 8 power n. Now the power n, you can do what? You can shift to the front, correct? So I'm going to do that straight away. So I get n log 9 over 8 base 10 equals to log 15 over 13 base 10. So now you can find your n value, which is log 15 over 13 base 10 divided by log 9 over 8 base 10. So when you calculate this in your calculator, you should get 1.215 years. Since the question is asking what year will the house exceed $300,000, you can say that it requires approximately 2 years. Correct? Approximately 2 years to exceed RM 300,000. The air pressure at a height of 10 km above sea level is given by, so they gave you this is the air pressure, where H is the height and E is equals to 2.718. Determine the height above sea level if pressure at the height is 380 Hg. So what they are trying to tell you is they gave you the pressure formula. Pressure is equals to 760 E power negative 0.125 H. Okay, so this is the pressure formula and the H here is the height. So now they're asking you to find the height, okay, given that the pressure is what? 380. So you just substitute 380 equals to 760 minus 0.125 H. So first thing you're going to do, shift the 760. You get E power negative 0.125 H. So 380 over 760, you should get 1 over 5. Now, if I get 1 over 5, now here I got E, right? If I bring E to the other side, what do I get? I get ln. Remember, I told you that 5 power x equals to 10, let's say. So when I bring the base 5, okay, the indices here, the base is 5, correct? When I bring the 5 to the opposite side, it becomes a log base 5, okay? And vice versa, which means you can also bring the 5 here, the base 5, to the opposite side, it becomes a indices, okay? So it works both ways. So in this case, here is e, correct? So if I bring the e here to the other side, it becomes log e, correct? So log e is equals to what? Log base e is the same as ln, correct? So in other words, when I shift there, I should get ln 380 over 760 is 1 over 2 equals to negative 0.125 h. So how do you find h? h is equals to ln 1 over 2 divided by negative 0.125. So that will be your answer. So when you calculate, use your calculator, you should get 5.545 km. Alright, so we are at our final subtopic and we'll cover 2 application questions, alright? So let us go straight to the question. So first one, a gardener observes a bug infestation towards plants in his garden. He finds out that the area of insect infestation towards his plant is, they give you the area, the formula of the area, where n is the number of weeks after the first week of initial observation. How long will it take for the insect to infest an area of 5,000 hectares? So here, they gave you the formula, right? They tell you that the area is equals to 1000 times 2 power 0.7 n. N is what? N is the number of weeks, okay? The amount of weeks. A is the area where the area of the plantation that's get infested by insects. So now they ask you to find what? How long will it take? So they want you to find the n value, correct? For the insects to infest an area of 5,000 hectares. So you just have to substitute this into your area. So 5,000 equals to 1,000 times 2 power 0.7 n. First thing I'm going to do, shift the 1,000. So I get 5,000 over 1,000 equals to 2 power 0.7 n. So 5 is equals to 2 power 0.7 n. Now, some of y'all might have the idea of shifting this, correct? When you shift, it becomes log 5 base 2, correct? The thing is, you can do that. You still get the same answer. But some of y'all are using the older calculator, correct? And the older calculator, as far as I know, is that you don't have the ability to change the log, the base value. Okay, all of y'all only have log. There is no log. There's no log base 5 or log base 2, you know. All of y'all only have the button log. So that means your natural one is log base 10. Okay, your natural button there in your calculator is log base 10. So in other words, you won't be able to solve this because this one is log base 2. That's why you cannot use this method. But if you're using the newer calculator, I think you can do that. Okay, so in this case, how do you solve it? Since you cannot change, so what you do is, this is 2, right? So you just add log on both sides. So if you add log, automatically we know it's log base 10. Log base 10, 2 power 0.7 n. So now this you can bring to the front. So log 5 base 10 equals to 0.7 n log 2 base 10. Okay, so I'm going to continue here. So you're going to shift this guy to the opposite side. So you get log 5 base 10 over log 2 base 10 equals to 0.7 n. So this, when you calculate, type in your calculator, you should get, actually you don't have to shift one, you can shift both. In fact, you can shift even the 0.7. So you get here 0.7. So here you're left with n. So n value is equivalent to 3.317 weeks. So what does this mean? This is equivalent to roughly 3 weeks and 2 days. Now if you don't know how to count this, remember here is 3 means 3 weeks, okay? 0.317 you times 7, because 0.317 weeks you times 7, you get roughly 2 point something, so it's about 2 days, okay? 2 point something days. Okay, I'm just giving you a rough answer here, but you should get 2 point something days, so you round up to 3 weeks and 2 days. Okay, so that's how you solve this question. Next, the electric current that flows in an electrical circuit for t seconds after its switch is turned off is, okay, they gave you the current. So what they're saying is, whenever there is current flow in the electric circuit, whenever you turn off, there will still be a bit of current in the circuit. Okay, so it takes time for it to die down to become 0. So this is the formula to show the amount of current in the electrical circuit depending on the different time. Okay, so the question is asking you, calculate the current flow when the switch is turned off. So when the switch is turned off, what is the time? Time is 0, correct? That's the starting of the calculation. So I is equals to 32 times 4 power negative t, right? So in this case, when you just turn off the switch, when you just switch off, the time is equal to 0, so 4 power 0. So I is equals to 4 power 0 is equals to 1, correct? Whatever value it is, 4 power 0 is always equals to 1. So your answer is 32 ampere. Okay. Question B. So calculate the current flow after 1 second. So 1 second, just substitute 1 there, equals to 32 times 4 power negative 1. So 4 power negative 1 is the same as 1 over 4. Okay, this is Indices chapter. Okay, so 32 divided by 4, answer is 8 ampere. Okay, next, the second one, calculate the current flow after 2 seconds. So I equals to 32 times 4 power negative 2. So 32 is what? 4 power negative 2 is 1 over 4 square, which is 1 over 16. So your answer should be 32 times 1 over 16, you get 2 ampere. Alright, last question. How long will it take for the current to reach 0.5 ampere? So now they gave you the current. So 0.5 equals to 32 times 4 power negative t. So you want to find the time. So in this case, you must first shift the 32. So when you shift 32, you should get 0.5 over 32 equals to 4 power negative t. So 0.5 over 32 is 1 over 64 over 4 power negative t. So I'm going to bring this here first. So 1 over 64 is the same as 64 power, or I can do this. 1 over 64, I can change it to base 4, correct? So I get 4 power negative 3. Because why? 4 power negative 3 is also the same as 1 over 4 cube. So 1 over 4 cube is 1 over 64, correct? So it's actually the same thing. This is under the indices chapter, right? If you're not sure, please revise the indices part. So 4 power negative 3 is equals to 4 power negative t. So in other words, t is equals to 3. 3 what? This one is what? They say t seconds. So this is 3 seconds. Alright, so that is all we have got to cover for this chapter. I hope you find this useful, and I hope to see you all in my next video. Right, take care.